Greetings! In this video, Yara Hidalgo is working with her 6th grade class. During this lesson, students annotate word problems and utilize an operation word model to determine the operation needed to solve each word problem. In this part of the lesson, Yara has just reviewed the meaning of the term extraneous, and is continuing to review the classwork instructions. She is about to introduce an annotation strategy for students to apply while decoding the word problems to support them with determining the operation needed to solve the word problem. While you watch, please consider the following focus questions. First, how and or where do you see writing and or reading in this lesson? Second, how is the organization of information in mathematics texts, for example, reading a graph, explicitly taught to students? Third, how does the teacher provide feedback and facilitate self-evaluation of mathematical literacy?
It says cross out any extraneous information. Sometimes word problems give us extra information that is really unnecessary. We don't really need to know, so we're going to come across that. And we're also going to distinguish what those are, so that way it doesn't throw us off when we're trying to solve a problem. It says circle the operation you need to use to solve a problem. You do not need to actually solve the problem. So right here what we're doing is we're looking at our list of words and we're trying to decide by decoding these word problems, we're going to decide, is it an addition, a subtraction, a multiplication, or a division problem. Okay, so everybody has their highlighter and everybody has their pen, their pencil. We are going to be highlighting important information. So let's go ahead and make a key here. We're going to highlight important information. Sometimes those are numbers. Important information, important numbers. We're going to circle clues, operation clues. Clues that tell us what operation we're going to be using. And then we're going to underline the question. And then we're going to cross out irrelevant information. Okay, that's kind of like a key as to what we're going to be doing in this word problem. Anybody have any questions? Okay. Go ahead and first one. Yeah, let's do the first one. You want to read it?
I'll read it.
Okay, let's start by reading it, and then I'll ask what operation we get. Go ahead and read it, Caitlin.
There are 5 calories in a candy bar. How many calories are there in 3 candy?
To support students' reading and decoding of the first word problem, Yara is about to start modeling how to use the annotation strategy she introduced earlier. As she models how to use the annotation strategy, she will call on students to make it an interactive process and provide verbal and nonverbal feedback to students to support their thinking.
Okay, first we're going to start by highlighting important information. What is the important information we need to highlight? Ace?
That there is 5 calories in a candy bar. And
5 calories in a candy bar.
there are 3 candy bars.
There are 3 candy bars.
That's pretty much it.
What's a clue that what's a phrase or a word that might give us a clue as to which operation we would be using? Yeah.
I think it's the plus the...
In the word problem, honey.
Oh.
Which word from these?
Oh.
Which word in the word problem tell us which operation will be used. Which word? Number one's a little tricky. Yes, Jacob?
How many?
How many? Not necessarily, because a lot of problems will ask us how many, but that doesn't necessarily tell us which operation. Owen,
Total?
number one, does it say total?
In this next segment of the video, Yara is about to reference the operation word model she shared at the start of class to further support students' reading and comprehension of the word problem. The operation word model supports students with decoding the word problem because it provides a list of clue words in a graphic organizer for 4 math operations: addition, subtraction, multiplication, and division.
What we're doing is we're looking at the word problem and we're trying to see what phrase or word in the word problem gives us a hint that we are going to either add, subtract, multiply, or divide. Maria,
Are there?
are there? Okay. Is are there here? No. Okay. Leo? In.
Yes.
Right here. That's why I added in, and I asked you to add in.
Sounds like
because-
2 ends.
Yeah, because sometimes it'll say it more than once. Because it tells us that, so, okay, before I get to that. Now we're going to underline the question. So let's go ahead and underline the question. How many calories are there in 3 bars? Is there any irrelevant or unnecessary information that the word problem is giving us that we need to cross out? No, everything's pretty necessary, right? So there are 5 calories in a candy bar. So in 1 candy bar, there are 5 calories. How many calories, the question is asking, how many calories are there in 3 candy bars? What type of problem is that? Addition, subtraction, multiplication, or division? Multiplication, circle the X. We're not solving the problems, we're just trying to identify which operation the problem